In this video, we are going to be learning about how to solve one-step equations, and this is the third video in our booklet series of Solving Equations book. Okay, so you should be on your one-step equations page. Now, to solve one-step equations, you are going to be performing the opposite operation in order to isolate the variable. Okay, now that all sounds really, really scary, but these are all things that you've actually done before, or you've done already. So basically, when we say isolate the variable, all that means is you are getting the pawn all by itself. Okay, so when we isolate the variable, it just means I am moving around those number cubes and I'm moving around those pawns so that on one side of my balance scale, I have just one pawn so I can figure out what its value is. And what you did with your hands-on equation set is, whether you knew it or not, what you were doing is you were doing the opposite operation of whatever was written on that equation. Okay, so what do I mean by that? Well, we have here in our first example, m minus 3 equals 8. All right, so far with our hands-on equation set, we've only been working with positive values or positive constants. So you took them away, so it would have been like a plus 3. And in order to remove that cube, you then did a minus 3. Well, using that same logic, if you were to start with a minus 3, what would you do in order to remove that term? Well, you would plus 3, right? So you do the opposite operation. So if it's subtract 3 from the variable, you are then going to add. And we know in order to maintain balance, what you do to one side, you have to do to the other. So we're going to do plus 3. Okay, so in the same way we do our legal moves where we took away pawns 2 at a time, in this case, or number cubes, in this case, you then would be adding number cubes to both sides at the same time. So this would minus 3 plus 3, it would then eliminate that term. They would cancel out, and what you're left with is you bring everything down. So m, you have an m. This now cancels out, is equal to, you have 8 plus 3, which is going to be 11. And notice how I'm using the colors that correspond with our hands-on equation. So this would represent the pawn, and this would be a number cube. So I now have as my final answer, m equals 11. All right, so let's go back through and substitute 11 in with our variable and see if it makes sense. So 11 minus 3 equals 8. 11, 10, 9, 8. 8 equals 8. That's true. Okay, that checks out. That balances. We know we have the right answer. So I do the opposite operation. Okay, here's another example. So we have 4 equals 7 plus x. All right, so sometimes your variables are going to be on this side of the equation, and that's okay. Remember, it's just a balance scale. So sometimes your pawns are over here, and sometimes they're over there, but the same rule applies. You want to isolate the variable. You want to get x by itself, or pawns all by itself. Right now, 7, think of it like a red number cube. It is a positive number, and in order to get rid of it, we then need to subtract. So we are going to subtract 7, and we need to do the legal move. So we are going to remove 7 from each side. Okay, so I'm going to write sub for subtract. Sub for subtract. There we go. Okay, so I'm going to bring down my x. 7 minus 7 is 0, so that term has been eliminated. That is good. And now I have 4 minus 7, and that's going to give me a negative 3. And so we can rewrite it the other way, x equals negative 3. Now, let's go ahead and check to see if this is correct. So that negative 3, we're going to substitute it back in for x. 4 equals 7 plus negative 3. 7 plus negative 3, yep, that's a 4, equals 4. and that's a true statement. So check, I know I did it right. Now, all of this checking your work can be done to the side or can be done in a margin. It's totally fine. I'm just writing it below here so you're reminded that you should be checking your answers, and that's how you do it. All right, the next ones, we have 7p equals negative 42. Okay, so let's think. What is this representing? So 7p, so that means 7 pawns. So I have 7 little pawns lined up on this side equals, and then I have a negative 42 number cube. Okay, so if I have 7 pawns over here, that means 7 groups of pawn, or 7 times p, or 7 times pawn. So I need to do the opposite operation. So I need to divide by 7, because right now that's multiplying by 7. Okay, so I'm going to divide by 7. Right, because you do the opposite operation. And what I do to one side, I have to do to the other. Notice how my notation is I'm putting divide by 7 this way with a horizontal line. It's like a fraction bar or a division bar, 7. All right, and let me just put the little note there, divide. Okay, so 7p divided by 7, I'm just gonna get p. So it's basically 7 pawns, but I want the value of 1. So I'm gonna divide that by 7. So I'm going to divide that by 7. So negative 42 divided by 7 is going to give me negative 6. Okay, so now let's take this negative 6 and substitute it in for p in order to check to see if we're right. 7 times negative 6 is negative 42. Negative 42 is equal to 42. Okay, check. We got it. All right, last example. All right, so sometimes you're going to have c over, or c divided by a number, in this case c over 3, or which is going to be equivalent to, and I'm going to put that over here in the margin, 1/3 c, or 1/3 times c, or c divided by 3. Okay, so these are all equivalent ways to think of or write that. But algebraically speaking, in that language, this is the correct format. This is how you want to write it and think of it. All right, so I now have c divided by 3. Now I do the opposite operation. So if currently c is being divided by 3, or we have 1/3 of c, which think of it like 1/3 of a pawn, right? So let's like draw a little pawn over here. And we have, okay, so we have 1/3 of it. We want to know what is the value of the whole pawn. So if this pawn, this little bit is 6, 1/3 of it is 6, and then that's a 6, and then that much must be a 6. Logically speaking, we know that the whole entire pawn should be 18, or 3 groups of 6. But how do I show that algebraically? All right, so I need to undo it. So I'm going to multiply by 3 to that side, and what I do to one side, I need to do it to the other. Multiply by 3. So that, let me write multiply so you don't forget. Multiply. So that just then gives me c by itself. Okay, and that is equal to 6 times 3 is going to be 18. Okay, so we know that the entire pawn or the variable is 18, and we're going to take that and substitute it back in. 18 divided by 3 is 6. 6 equals 6. True statement. Check. So we know that we've done that one correctly. Okay, so the big takeaway of this is you always perform the opposite operation in order to isolate the variable.